All right, so I got it up on the screen here. It says examine your selected object and the construction you made. Are there any transformations? Yes, there are. There are only horizontal and vertical translations. That's it.
Yeah, there's obviously no like reflections or rotations. There's only translation.
Now you might want to be more specific. You might want to say that the and this is where you get into the language, the original image or the original triangle was translated, and this is where you say, 11 units. What do you say here? 11 units
11 units. It's 11 units for the x-axis and the y-axis. So 11 units
to the right,
to the right.
and 11 units up.
Yeah.
And so you probably want to be that specific with your teacher here, kind of like we've learned over the past few lessons. Give them more
Detail and like be more specific about like I think that's what just kind of trying to get at in the last few lessons. So yeah, that's good. All right. So let's see. Yeah, so here pretty much we're just explaining like the translation and how much on the right to the right and how much up, how many units up and how many units to the right that we're going. Got it.
So that's part one, or that's one of part B.
Yeah. And then use complete sentences to describe. I think that what uh what does exam?
So it says use complete sentences to describe the transformations present in your construction. So that is, so I guess the answer is,
Yeah, cause I was looking at those two and it kind of seemed
so the
because
first one you would say, yes, that's the transformations.
so yes, there are
Yes, the
transformations.
transformations are translations.
Yeah.
That's for one.
Yeah, because I'm just asking, are there transformations like
Two,
rotation? And then two kind of goes more into depth, and then
yeah,
kind of
uh,
says, yeah, all right, got
you
it.
would say the original triangle was translated 11 units to the right, horizontally. Maybe indicate that's horizontal, 11 units up, vertical.
All right. So for number one, yes, there are transformations, which are transformation is a translation. Period. Number two would be the original triangle is translated by should I still keep should I keep the plus or just get rid of the plus and just put 11 units to the right and 11 units up?
You just have to say the direction. I mean, you're trying really hard to give this more than you need to.
All right, so translated by 11 units to the right on the x-axis and 11 units up on the y-axis. All right, let's fix something there.
All right, there we go, right there. Sorry.
All right, there. Oh, yeah, there we go. All right. So that let me just quickly attach this to to there. 1 second. I think that's all they're asking for that activity. What, I didn't miss anything else. It was only those two. Yeah. Yep. All right. Very good. Let me just put this. Extension. All right. Good. Very good for that. I've got to have some time. So I was thinking we'd go ahead and go on to. There is a here. Let's see if there's anything important. All right. So now I'd like to go over the test part 2. This is the one that's the written again, kind of like the last one. Should be pretty similar, just a bit different in the question type, obviously. But, all right. This one's 4 questions. Let me put the first one in the chat now. Okay, let me touch this. All right, there we go. All right, it's in the chat.
If the triangle ABC is translated according to the rules x, y, x minus 4, y plus 3. Okay. All right, so I'm going to show you how to do this in Desmos, because I think that could be a useful thing here for you in the future here. So I'm going to new share another window here. Hopefully you can see that now. There you go. So what's really neat about Desmos is you can actually graph the ordered pairs. Maybe you already know this. You can label them with A, for example, and do the same thing for B. Have you done this before?
Um, yeah, have you? Yeah, I think I've done
You,
it. Yeah, or
okay. Now, what I'm seeing here, which is nice, is this is a right triangle. One of the things it's a little bit more difficult, and someone may have figured out how to do this in their software, is to construct the lines. It's a little more complicated to do, so we'll just visualize that there. And
yeah, but
then
you can kind of see if you were to like draw through the points, you would probably get like a right triangle because you can if you
that's
were to.
right. That's right. So what I'm gonna do is just snip this back into the other screen, and we'll talk about, we'll maybe go back and forth here a little bit, but I wanted you to see that to start. So first thing is you have kind of this original ordered pairs here, right? And then that's your A, your B, and your C. And like you said, you can visualize that drawing here. All right, now this x minus 4 literally means up here, it literally means to subtract 4. So -7, -7, -11. And notice I do it all together. The way the brain works is we're really good at doing one thing at a time. We actually can't multitask. Even if people say they can, they're not. You're always switching between tasks. So it's easier to just do one thing over and over again. The y, you're actually adding 3. That's 4, 7, and 4. These are your new ordered pairs. This is your A prime, your B prime, and your C prime. Now, in terms of what you're actually doing, when you look at this, you can actually tell from the equation But if you're not sure, you just go and graph it. So I'm going to do that in the other screen there, and hopefully, and I'll snip it in here, but maybe you already can see that it's moving horizontally and vertically. So give me just a moment here to get this graphed, and then I'll snip it in.
Yeah, no problem.
One of the first things you always do when you're given a data set is, and this isn't really a data set, but it's always good to visualize your data. So it's good to know, like, what does it look like? And hopefully we'll do a context to this. So let me snip this in. Again, this is all for part A. So that, here's your original triangle. And you do have to know which one was the original, because it does matter whether you're moving up, down, left, right, but there's your new one. So notice A is still this lower right vertex, B is B prime, C and C prime. So you can see it moved left and then up.
Mm.
Okay, and so this X minus 4 means left 4, Y plus 3. Sorry, I gotta make sure I go get that.
So
Plus 3 means up 3. So in terms of how to answer it, well, I guess I've done more than I needed to here for part A, but in terms of how to answer part A, you want to say that this is a translation horizontally left 4 units and vertically up 3 units.
as
Every X value is decreased by 4, and every Y value is increased by 3. And so this other stuff I've done is really applicable to parts B and C.
units 30 units per units the X axis units on Y axis. Every vowel XY is decreased. Right. Is decreased. And every YY increased by 3. And every Y value increased by 3. All right. Yeah, I get that part now.
So part B's got a little bit, probably mentioning this
There.
snip of part B here.
Whereas the where are the versions of A prime, B prime? Oh,
So part B, I'm just going to move some stuff around here. So
yeah, no,
part B is really done right here. It's right here in this table. Okay. And so you want to explain that, and I'll type this. You want to explain that these are your new XY values. So X prime, Y prime, basically. You want to explain that, well, I mean, we actually said that right here. It's right. I don't know. They're this is how you're saying it. Every X value is decreased by 4, I mean, you're subtracting 4, and every Y value is increased by 3. So that you want to say, maybe start out by saying something like this, like make a table with the original XY pairs and create the new ordered pairs for the transformed image. And you're explaining that to do that, every X value is decreased by 4. Maybe you could just say, you could just be more just direct, subtracted by 4, and every Y value is added by 3.
Got it.
And then you might just say that you graph the result and maybe show it. I think that's kind of being that A+ student. So, showing it here would be good,
Yeah,
especially with the new, something like that.
got it. Eh, Uh, I'm just gonna put part A just to make it clear for not, then put part B for this. So part A, B. So make a table, original X comma Y comma Y pairs to create the new ordered pairs of treatment. Every X value is subtracted by 4. Every Y value is added by 3. And graph the result. Let me just quickly. Me insert. Second, let me just. There we go. All right. And then part C.
Yeah, so part C here is we're modifying that new image. So it's this triangle. ABC is rotated 90 degrees. Now I'm going to put in the chat a link to a reference sheet. It's got all the transformations in one place. Translations, dilations, and rotations. It's kind of students call it a cheat sheet. It's just a reference sheet. But the direction that you rotate matters. It's 90 degrees. The angle matters and the direction. So in this case, we're doing 90 degrees clockwise. This is our rule. Okay, so you're again taking this table of values. Okay, so we need these
So,
original values. Let me grab them here.
in other words, we're taking each of the coordinates and we're applying that rule.
Exactly. And if you know the rule, it's very easy. If you don't know the rule, you can do it. It's harder. What it says here is take the Y value and put it where the X is. And you want to do them all the same. So take the Y value and put it where the X is, 4, 7, and 4. Again,
And
it's
then,
easier for the brain to do things all the same
and
way.
then the other side would be 7, 7, and 11 because it's a
Exactly.
negative there. So negative would be positive. So
There you go. And so now you go ahead and you graph it. I'm going to go ahead and do that as well on the Desmos and snip it in. I think it's useful to see. We don't need the original anymore, but we do need the new point. So let me get that in. It's true, a picture is worth 1,000 words. It's very nice to see this again for labeling purposes, A double prime, B double prime, C double prime. 7 comes 7. Hopefully, like I said, you've seen these before, these rotations, these transformations, maybe even did some dilations in the class. All right, so here we go. I'm almost ready to snip this in. Now, very common is that you switch quadrants when you do a rotation. Especially,
Yeah.
and it shouldn't surprise you, but uh, it sometimes students need to be told that. So here's the rotation. Clockwise is this direction. I like to kind of show it. And CW means clockwise. That's always kind of a nice thing there. All right, now that's not the answer though. That's just like a nice friendly warm up here. So to prove congruence, there are a couple of ways to prove congruence. Have you, well,
Um,
like I can give you the answers, but
like,
do you know any of the ways to prove congruence?
I know, here, let me have a note here. Wait, all right. I know the side, if I'm proving stuff, I know that the side postulate, the side angle side postulate,
What?
the angle side angle postulate, the angle side postulate, and the hypotenuse leg theorem, which I guess is like a you can use to prove it.
So the best ones to use are the ones where you do the least amount of work, truthfully. Um, these are both 90-degree triangles. We would have to prove that, but then you would use hypotenuse leg for this one, which means proving that the hypotenuses are the same lengths and that one
So
of the
therefore,
legs.
the yes, the legs are the same length and the hypotenuse is the same length. Then you can
y-
prove that.
Yes. Now to prove that it's a right triangle is you have to show that the slopes are orthogonal, and that can be done pretty quickly. If you don't want to do that, if you want to use side, side, side again, you have to do the same thing you did in the previous
Yeah,
problem. I mean,
use like the distance. Well,
yeah, not well, but here's the thing, because it's a nice right triangle, you can
yeah,
prove pretty, you don't even have, I mean, you're just literally counting here. Like this one's 4, this one's 3,
yeah. If it
and
was like
then you'll,
I think the reason why I used like SSS to do the scaling one, the reason why they had you use SSS is because there's no like clear count. You can't just count the squares with the scaling obtuse triangle. The one in the activity.
and that's, I would probably use SSS here, I guess, because it is so easy. I would, um, you just have to specify the length from A prime, B prime is 3, A prime,
Yeah.
C prime is 4.
Or and then C prime B prime would be 5.
Yeah, and just be consistent with your order, and then
And
you do
then
the,
you to put A double prime, B double
yes.
prime, and then kind of show it like that.
I think that's enough. Um, you might say off to the side here that you're just count use your, I don't know, you're using observation. I mean, you're counting. Um, should be okay.
This- Should I just explain it that after rotating A prime, B prime, C prime to get A double prime, B double prime, C double prime, um, that it would be congruent because use what, um all
I
the
think,
side lanes are the same.
yeah, I think you have to add some of those sentences. You have to say, make a table, uh, for the new triangle with the rotation, indicated rotation. Um, the new triangle is congruent by SSS because, and then that's where you have to show your calculations. Like these calculations come after.
Got it. Just show that. Yes.
And you might add in there that while the distance formula is often used to calculate the length of sides, when the side lengths meet or fit nicely on the grid, counting as an acceptable substitute. Did you see the Pythagorean theorem though yet in the class?
Um, not in this specific class, but I have seen it before, yeah.
Okay, so then you because somehow you can't count the hypotenuse. So you would have to use either the Pythagorean theorem or the distance formula for that. So you may have to show that calculation for the,
Yeah, probably. I could just quickly show like that.
yeah,
Yeah, it would just be like a squared plus b squared equals c squared. So
yeah, you just gotta make sure you show it though. That's the key. However you want to show it, you end up getting the square root of 3 squared plus 4 squared. Can't be too careful with the feature. Gotta make sure you get the maximum points.
so right now I put for C, the first thing is you make a table for the new triangle um with the rotation like that's given
And hopefully you're showing that as well somewhere.
yeah,
Okay, good.
given rotation, the new triangle is congruent by SSS because, and then should I put the like the calculations and everything after the
Yeah, well, or
because
you
and
want to say
then just
because all sides are congruent, and then you want to actually show that.
because all sides are congruent, right? Um Should I put the part where it's while the distance formula? Just put
No,
that out.
no, no, you just need to indicate that you need to show the distance formula. You got to show that you're using that somewhere.
All right, yeah. Just put another image or something like that. Yeah. Okay. All right, so then. uh, So the new triangle. Right, so this had to show me like using the Pythagorean theorem to find the hypotenuse and showing the distance formula.
Yes.
All right. Hey, number two. Okay, number two is in the chat now.
So determine if these two figures are congruent and explain your answer using transformations. Yeah, you got to kind of pick a starting point. So we'll just start with A, B, C, D. And so that means just in terms of like a path here. Hope- Hopefully you kind of see what I'm talking about in terms of a path. You start somewhere and go a certain way. Your path here is G, F, E to H like that. Are these congruent? Well, um, it would require that um, well, figure out the transformations. So they don't require you to use, I guess they don't require you to use the distance formula. What you should do is label each of the points, the ordered pairs here. And then what you're looking for is some transformation that does this. Okay, so let me try to explain this here. So -1, 1, B is -3, 2, C is -4, 4, D is 0, 5, G is 0, 4, -4, F is 1, -2, and then C is, sorry, E is 3, -1, and H is 4, -5. So unfortunately, there's no like one transformation that's going to do this. It's some combination of transformations. So like typically you might think of like a rotation or a reflection or something that would get this done.
Got
Wait,
it.
wait. I'm sorry. I did this in the wrong order. That's why this is not working. I apologize. A corresponds to E. So A actually corresponds to E. So we got to move some of this around here. Oh boy. That's why this wasn't working. I'm like, why this is really bad. All right, so E comes first. E comes first. So you're actually starting at E, and then you're moving to F, and then G, and then H like this. So let's get that. Because that allows you to sort of see some transformations possibly here. Let's see if we get this last one. Yeah. Okay. So now it's correct. And I don't know why that happened, but you got to be very careful here. So what I'm noticing is that all the Y values are negative of these Y values. Do you see that?
Yeah.
So what do you remember what causes the Y values to be negated? What kind of a transformation?
Um, there's
It's in that
it's a
thing I sent you on in the chat, that link.
I think
And I can
it's 90 or which it's so it would be 90 counterclockwise.
that does do it, but it just this one is over the x-axis. Over the x-axis. So like imagine this original one was just flipped over the x-axis. Let me draw that down here. I think that'll help here. And this is a very visual exercise. It's not an intelligence thing. It's just a like, can you see it? Are you a visual person? And not everyone is. Not everyone is. So if you reflected that original over, oh, that's drawn so poorly. Why is that? Oh, because I got that one in the wrong spot. All right. Okay, so there's the original reflected over the x-axis. Do you see that?
Yeah.
Now maybe you see it that now everything is pushed to the right to get to this new one. Well, it's like, well, how many units? Well, this point up here where my cursor is moving 1, 2, 3, 4. This point here is moving 1, 2, 3, 4. This next point is moving 1, 2, 3, 4. This point is moving 1, 2, 3, 4. Now, when I start looking at the X values, to the new X values, I notice that they all go +4. Is 3, 4 more than -1? Yes. Is 1,
Yeah.
4 more than -3?
Yeah.
Yes. Is 0, 4 more than -4? Yes.
Yep.
It's 4, 4 more than 0? Yes. So there you have it. There's your transformation. So the order doesn't matter because but you will say that it is I mean it actually doesn't matter. So you can either say it's first, it's a reflection over the x-axis. This causes all the y values to be negated. Second, it's a horizontal transformation. Right. It's really a shift, but I guess your book uses translation, translation or units to the right, affecting only the x values. I mean, it's kind of obvious, but that's how they're doing it. So they are congruent. You do want to say that. So you want to be very specific. You want to say that figure A, B, C, D is congruent to E, F, G, H. Maybe just say that there are two transformations These teachers really like this. I don't know. I prefer more of the explanation like we just did, talking through it, what you see.
Yeah. Alright, so,
All right, so make sure you get this down. We got a couple minutes left. I want to make sure you get all this down. I don't want you to be stuck in the middle of a problem here before we close out.
alright, I got that down. Go res. Alright, I got this in the chat. What? Okay. This one, but
Looks like you just sent something over here. There's probably no way we can do this, but I'll definitely snip something in here if you want us to try to work on it. So first thing you might do is just draw two arbitrary triangles that look the same and label them the same way, like GHI, RST, and then start labeling the indicated stuff. Like since angle G is congruent to angle R, and H is congruent to S, and GI is congruent to RT. So is this enough?
Yeah.
Through SSS? The answer is no. The short answer is no. It's actually angle, side. And that's as much, I guess, as I can do and or give you in our time today.
alright, yeah, I can probably continue
That may
from
be
there.
enough. That may be enough. Yeah. So we got a lesson tomorrow at 4 o'clock. So we'll just